And okay, so now let's review what we learned the other day about how to graph what's called a linear equation. Let's remind ourselves, it's called a linear equation because the exponents, we don't see any exponents, are understood to be 1. There's no higher exponents. There's no x squared. There's no x to the third. The variable's highest exponent is 1. It's called a linear equation or a first degree equation. Those two things mean exactly the same thing in terms of the type of equations that they are. Okay, so I'm going to go through the graphing of this using two of the methods that we talked about. One is the intercept method and one is the slope intercept method. So let's first talk about the intercept method. The word intercepts, let's remember, means where it crosses either the x or the y-axis. Here's our graph. Fortunately, it's not very straight because it probably looks even more crooked when you're looking at it, because I always notice that the lines are somewhat off. Okay, but this is what's called the Cartesian coordinate system. This is the graphing that we graph flat surfaces, not just a line graph, it's a whole plane, it's a whole board, so to speak, that we're graphing. And we're going to, this is a first degree or linear equation, and it's called a linear equation because when we graph it, the picture we get is a line. Now, as I said, one way is to find the intercepts. So to find the intercepts, we have two intercepts. We have the x-intercept, which we find by setting y equal to 0 in the equation. Now that really is quite easy, because if you look at, you could actually do the substitution, but anytime a variable turns out to be 0, it basically, no matter what it's being multiplied by, it basically disappears. So if the y is disappearing because it equals 0, what we're left with in that case is that 2x equals -20. And when we divide by 2, we get that the x is -10. So we have the x being, the x being -10. The y, of course, we just said, we set it equal to 0. The most proper way of saying it, to say the x-intercept is the point parentheses -10 comma 0. But if you just say that the x-intercept is -10, you're really giving all the information, and that is considered a correct answer as well. So what does that mean? It means if we go to the -10 on the x-axis, okay, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is the x-intercept. We know the line that we have to draw has to go through this point. But of course, there are many directions that a line could go through that point. So to find another point, we could do it by plotting points, but the other way, if we're doing the intercept method, is to not only find the x-intercept, but to find the y-intercept as well. And that we do by setting the x in the equation equal to 0. So just think about it. You want the x-intercept, put the y 0. So you're just left with x's. If you want the y-intercept, put the x equal to 0, so they only have an equation with y. In other words, then your equation becomes negative 5y equals negative 20. And if you solve that equation, you get y equals negative 20 divided by negative 5 is positive 4. So our y-intercept is 4. Again, we can say the y-intercept is 4. The more correct way of writing it is to say it's the 0.04. Remember, when the y-intercept will have the x equal to 0, because it's going to be on the y-axis, the x-intercept has its y coordinate equal to 0. Okay, so therefore, we go up 4 on the y-axis. And now that you have these 2 points, you now can draw your line through those 2 points. A straight line, I know this doesn't look very straight, but you're going to have to bear with me. But you only need 2 points to draw a straight line. And there's only one way of drawing a line between 2 points. Sometimes this is said, the 2 points determine a line. If you have 2 points, then you can draw the line. So this is one way of doing it. It's called the intercept method. You find both intercepts, and then you can draw your line. The only time this would not work would be if you only have one intercept. Sometimes it only goes through the origin. That would be the only one. Or sometimes it goes straight up and down, and sometimes it goes straight across. We're going to talk about those special instances in a little while, but let's redo this example. Keep the picture. I'm going to have to erase this whole thing because obviously the board is not big enough. I'm going to do it by the other method, one of the other methods that I talked about, and that's what we call the slope-intercept method. So is everybody, can I erase this? Everybody okay with that? Okay, thank you. So, you're going to see the picture we're going to get is going to be an identical picture. It's just a different method. The method that we're doing now is what we call the slope-intercept method. And what we do is we find the y-intercept. So that's something we already did. So that's not so different, but we also use what's something called the slope. Now, in the slope-intercept method, we have to put the line in what's called the y equals mx plus b format. We have to solve the equation so that we have the y alone. And the way we do it is we take our original equation, and the y is our variable, and we look at anything else as just regular numbers and think, what would we have done if this was a number? And that's exactly how we proceed. So let's take this equation, 2x minus 5y equals negative 20. So the first thing we want to do is get rid of this 2x because we're looking to get the y alone. So now always look at what's in front of it, not what's behind it, what's in front of it. I want to get rid of this 2x. It's really obviously a positive 2x because there's nothing in front of it, means it's positive. So to get rid of it, I have to do minus 2x from both sides. So I will be left with negative 5y equals. Now these are two terms that can't be combined because they're not like terms. One has an x and one doesn't. So we just write them each separately. And in order to put it in this format, we want the x term first. So I'm going to put the negative 2x first, and then I'm going to do minus 20. Again, if you have done first the negative 20 and then the negative 2x, it wouldn't be wrong. It's just that this is what we're trying to get it to look exactly like that format. Now, what we're left with, as we have a negative 5 in front of our y, we want the y alone, we're going to have to now divide by negative 5. We are not adding or subtracting. Negative 5y means the y is being multiplied by negative 5. You must divide by. The only time you add and subtract is if there's something in between the number and the variable. But if the number is right next to the variable, then you must divide by it. And of course, since I'm dividing by negative 5 over here, I've got to divide all the other terms by negative 5 as well. So this leaves me y, which is what we were looking for. Now this is negative 2x over negative 5. So first of all, a negative divided by a negative is positive. So this becomes 2x over 5. And then we have negative 20 divided by negative 5, which becomes a positive 4. And you could either write it this way with the x on top, or you could write it this way, y equals 2/5, and put the x next to it plus 4. It means the same thing. So we now have it in what we call the y equals mx plus b form. The m, which is what we call the slope, is the coefficient of the x, the number in front of the x, the number that's attached to the x. Now, it's not just the 2, it's the whole thing. It's 2 over 5. We like the slope to be a fraction. If it turns out to be a whole number, let's say there wouldn't have been this 5 and you would just add the 2, you would have written it 2 over 1. The b, which is what we call the y-intercept, slope, intercept. The m is the slope, the b is the y-intercept, in this case is 4. So once we have it in the correct format, we can right away tell you what the slope of the line is and what the y-intercept is. And if you recall from before, the method of finding the slope, the y-intercept, by putting the x equal to 0 actually gave us 4. So we're getting exactly the same answer, even though we're doing it a slightly different way. Okay, so here is our graph. Again, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, so we have this graphic. We're managing these lines going up and down. Okay, when we're using the slope-intercept method to find the graph the line, the first thing we look at is the b. The b is 4. That means, and that's my first step, I go to 4 on the y-axis. 1, 2, 3, 4. And it gives me my first point that I'm graphing on this line. I must start at the y-intercept. I then, to find other points, use my slope. My slope is 2 over 5. And the meaning of slope is rise over run, which means from any point on the line, and in this case, we only know one of them, you can get to other points by rising. That means going up or down. If it's positive, you go up. If it's negative, it's a negative rise, which means you're going down. And run means you go across. So to rise over run 2/5, you'd have to go up to 1, 2, and 5 over. 1, 2, 3, 4, 5. And you put a second dot over there. And that would really be sufficient for you to draw the line. But if you want more points, you can do it by just starting with this point and going up 2 and 5 over. Or alternatively, and this I usually do, is this is equivalent to saying, and we've even had it before, -2 over -5, because a negative over a negative is positive. I could have taken this as a negative to rise, which means go down 2, but then a run of -5 means go to the left 5. 2, 3, 4, 5. And trying to get it. And if you draw the line, notice the points line up. And if we would have drawn this one far enough, we would have ended up with it crossing. But if you notice, if you look, compare the two lines that we drew, the one before and this one, it is the identical line. Actually, if you ask me which method do I prefer, I usually prefer the slope intercept. The slope gives you a feeling. Let's talk about then the concept of slope. Now, before I do it, would you like to try one more just to make sure you understand how to do this using the slope intercept? Should I give you another one to try? Any comment? Yeah, okay. Great. So let's try one. And this one specifically, even though you can go use any method you want, I'd like you for now to use the slope intercept, the y equals mx plus b method. Okay, so let's say I give you this example. Three x plus 5y equals 15. By the way, this is what's called the standard format, where you have the x's plus or minus the y's equaling a number, is standard format. The first thing we're going to do is put it in the slope intercept, the y equals mx plus b format. So I'd like you to put it into the y equals mx plus b format, and then use that to graph your line. I'm going to give you about 5 minutes to try this. And while you're doing that, I'm going to take attendance. So listen for your name. Olivia. Olivia here. Olivia August. Isis.
Here.
Hi, good morning. Alvaro. Lewis Hart. Lewis Hart. Emma.
I'm here.
Hi, good morning.
Good morning.
Were you here on Monday?
I was, but I think I got kicked off and I was trying to
Okay.
join back.
Okay, so let me just stick.
Yeah.
Okay. I just want, I wasn't sure. I thought I had seen you and then when I took attendance, you didn't come on, so I didn't know what happened. Okay. Demetrius. Desmond Fleming. Desmond Fleming. Shania. Shania Haley. Caden Ricardo. Caden Ricardo Harris. Caden Ricardo Harris, not there. Okay. Kayla Harris.
Here.
Hi, good morning. He's not related to you, is he?
No.
Okay. I've had times siblings, so sometimes they have the same last name. Sanjita Hussain.
Yes, I'm here.
Hi, good morning.
Good morning, Professor.
Oriana Jonas, I know you're here.
I'm here.
Yeah. Tahira Joseph.
I'm here.
Yeah, good morning. Michaela Martinez. Michaela here? Kiana Perez.
Here.
Hi, good morning.
Good morning.
Were you here on Tuesday? I mean, on Monday, I'm sorry.
No, I couldn't join.
Oh, okay. I just wanted to make sure I'm taking attendance correctly. Carly. Hi, good morning. Jenna.
Jenna?
Yeah, hi, Jenna.
Hi, hello, good morning.
Tatiana Sanchez.
Here.
Hi, good morning.
Good morning.
Naya Sims.
I'm here.
Hi. Kazandu Small. Kazandu. Trainer Small. Jean Thomas. Okay, I'm still giving you a couple more minutes to work on. I will be posting more Delta math homework, but it will not be due until after the weekend, until Monday. Because remember, your first quiz has to be done by Friday. Give you the whole, I think it has to be turned in by 10 p.m., but make sure you give yourself enough time. You need 45 minutes to take it. And don't think you can sit 10 minutes and then go take a lunch break and then come back a half an hour later. Because first of all, if you turn off your computer, it's gonna submit the test and that's gonna be it. And if you run out of the 45 minutes, it's gonna submit the test and that's gonna be it. So make sure you're doing this when you have the time that you can sit and spend the time necessary to finish the whole quiz. I should not take you 45 minutes. I did a lot that it's 10 questions of the type that you've seen before on Delta Math and that we reviewed last week. Okay, so let's work on this problem. We said I told you I wanted you to do it in the slope intercept format. So we're going to have to solve for the y, get the y alone. So let's minus the 3x from both sides first, which will give me 5y equals negative 3x plus 15. Remember, these are not like terms, so we just have to keep them separate. And then we're going to divide by 5, each term by 5 to get the y alone. So we get y equals negative 3 x plus 3. And that means that my slope, that's my m, is negative 3/5. And our y-intercept, which is the b, is 3. So we've done the heavy work now. Now we have to go and put it on our graph. It's ready to be graphed. And remember, where is our starting point? Always on the y-intercept. You go on your y-axis, and you, since my b is 3, you have to go up 3 on that. And then you look at your slope. Now remember, our slope is negative 3/5. Let me just write it over here. Now, when you write, now this really should be written like this, with a minus in front of it, in front of the whole fraction. But what does it mean when you have a minus in front of a fraction? Well, you have two options. You could either call it the negative 3 over the positive 5, or conversely, you could do positive 3 over negative 5. The negative either goes in the top or it goes in the bottom. It doesn't go on both, because if it was a negative over a negative, the whole thing would have been positive. But you have your option of putting the negative. I usually keep the negative with the numerator. I find it's easiest to deal with the denominator being positive, and this way my denominator is always positive. So if I look at my slope as negative 3 over positive 5, that means my y is negative 3, which means I go down 3, 1, 2, 3, and I run 5. Now it's a positive 5, so I'm going 5 to the right. Again, I could just draw my line. If I want more points, I can just do the opposite. I can take it as positive 3 over negative 5, which means rise 3, but run about negative 5, which means go 5 to the left. Now you notice when I do this, the points all line up. If you were doing it on graph paper, it would certainly show. Make sure you draw your line longer than just from one point to the next, because a line extends infinitely. It's not a line segment, it's a line. How many people got something that looks like this? This is clear now. Okay, thank you, Emma. Okay, so I think we're okay with putting our line in what we call the slope intercept format and then graphing it. And very often our lines are actually given to us in that format, and it really makes it easier to draw the line. Now, just want to talk about a couple of special kinds of lines and how we can draw those lines. And those are the lines that are either totally going up and down, and the lines that are going straight across. Okay, so I'm erasing this, and I'm talking about either horizontal or vertical lines. So let's look at an equation like this. Y equals 5. What if I have an equation in which I only have a y and there's no x in the equation at all? Now, if you really think about it, the way that could have come about is if I had y equals, if I was trying to put it in y equals mx plus b form, it would be y equals 0 times x plus 5. Now, we never say this, but obviously, if there's no x, it's been multiplied by 0, which means the slope is 0. What do we mean by a line whose slope is 0? Let's look, how do we graph this line where all we have is a y and no x? Well, it's really quite easy. On your piece of graph paper, you go up to 5 on the y-axis, and you draw a line straight across. This is called a horizontal line. You know what horizontal means? It means go straight across, like the horizon. If you go out to the seashore and you look at the horizon, it's straight across. This is a horizontal line. It's parallel to the x-axis. And if that's why, no matter where you pick a point, this point on the graph would be the point, well, x is 0, y is 5. This point, which is on the line, is 1, 2, 3, 4 over and 5 up. In other words, it's 4, 5. Remember, the line consists of a bunch of points. What about this point? If I go 2 to the left and 5 up, I get to the point -2, 5. what is the thing that all the points on the line have in common? Their y value has to be 5 because they all have to be 5 up. So that's why the equation of the line is y equals 5. The x's can be any number because it could be 4, 5, 0, 5, negative 2, 5, but the y's are all 5. If I gave you the equation of the line y equals negative 2, then what you would have done is go down 2 and draw a line straight across. Here's your line, y equals negative 2. So very easy to draw the equation of the line horizontal to the x-axis. Its equation is simply y equals a number. And you look at the number, if it's 5, that means go 5 on the y-axis and go across. If it's negative 2, it means go down 2 on the y-axis and then go straight across. The slope of this line is 0. Obviously, remember what I said slope is? It's telling you rise over run. If you go from one point to the next, let's say go from this point to this point, I'm not going up or down, no matter how much I go across. So I'm always, my slope, my rise is always 0. So 0 over anything is always 0. Okay, let's now talk about a line whose equation is x equals a number. What if I don't have a y? What if I just have an x? So let's say I gave you an equation like this, x equals 3. How do you draw a line where the x is equal to 3? Well, we saw when we had a line that y equals 5, it meant all the points on the line had their y value equal to 5, and we got a line that was straight across. To say that x equals 3 means all the points on the line are going to have their x value to 3. In other words, I could have 3, 0 as a point on the line. I could have 3, 1 as a point on the line. I could have 3, negative 2 as a point on the line. All of these are points on the line because their x value is 3. Here we are. 1, 2, 3. Here's 3, 0. 3, 1. 1, 2, 3, up 1. 3, negative 2. Over 3, down 2. Notice all of these points whose x value is 3 line up in a vertical line. Vertical means up and down. And the equation of that line is x equals 3. Now notice you can't even put this in when you have y equals, so you can say the m is 0. But when you have x equals, there's no y at all. You can't even talk about it in the y equals mx plus b form. But anytime you see an equation of a line that only has an x and there's no y in that equation at all, it means that you're dealing with a vertical line. I know my line on my board doesn't look straight up and down, but it's supposed to be straight out and down, parallel to the y-axis. In terms of the slope, it has no slope. To say it has no slope means the slope is non-existent or undefined. I'm sure you've ever heard that term before. When we talk about something not existing, the only kind of numbers that we can't use in the real number system is a number where you have the 0, a fraction where a 0 is in the denominator. You can't divide by 0, which means you can't be 0, have 0 in the denominator. Anytime you try to write something that has a 0 in the denominator, you're getting what's called an undefined number. Undefined means it does not exist. does not exist. DNE does not exist. And that makes sense also because remember, we talked about slope being rise over run. So let's say go from this point to this point. I'm rising one, but I'm not running at all. I'm staying on the same, I'm not going to the left, I'm not going to the right. So I'm going one up over zero. Again, I'm getting a zero in the denominator that's not defined. So vertical lines have, you can either, the proper term is to say no slope. No, it doesn't mean it's a slope is zero. It means it does not exist. Sometimes also used the term saying undefined. So these are two simple equations that give us very special lines. If you have only a y in your equation, you're going to solve for the y and get that horizontal line. If you have only an x in your equation and no y, you're going to solve for that x and get that vertical line. Anytime you have a line that's slanted, either slanted to the right or slanted to the left, that is going to be a slant line always has both an x and a y in it, and it's, you can find out what its slope is, and the slope will tell you how much it's slanted. And the slope is very interesting. So let's talk a little bit more about slope. I'm going to go back to the two lines that we had drawn before. See if I'll remember them. One was the line, I think the first one we did was, y equals, somebody help me with this, what was it, y equals 2/5 x plus 4, was that what it was? Is that the correct, is that what the correct one that we got? Somebody help me with this. Okay, that was the first line. Well, even if it wasn't exactly this, let's assume it was. And the second one that we drew was y equals. I should keep notes myself. Negative 3/5 x plus 3. I think that was. In any case, let's look at these two lines and let's talk about, again, these are both, I'm giving you both of these lines. They're two different lines. They're in the slope intercept form because they both say y equal. And just as a reminder, the slope here is 2/5, because that's what the coefficient, it's called the coefficient, the number that's attached to the x. The slope does not include the x. It's everything except the x. And it has to be attached to the x. It can't be a plus or minus in between it. There has to be right next to the x. The y-intercept here is 4. Whereas over here, the slope is -3/5. And the b, the y-intercept is 3. And if we were to draw this line, just doing a little picture right over here. just reminding us, we'd start at 4 on the y-axis, and then we would go up 2 and 5 to the right. Or conversely, we would go down 2 and 5 to the left. And we got a line that looks like this. Now, if you look at this line, and as you go along the line from the left to the right, remember we've always, even on our number line, we always talked about starting on the left and moving to the right. If you go along this line from left to right, what's happening? You're going up. This is a rising line. You're going from left to right up. That's because when your slope is positive, then you're going up. Any line with a positive slope is a line that's going as a rising line. What about this line over here? Okay. This line has a slope of 3, a y-intercept of 3. So this line is going to start at 3. And since the slope is -3/5, we could either go down 3, 1, 2, 3, and 5 to the right. Or we could go up 3, remember this, we could put the minus in the bottom and go up 3 and 5 to the left. And we got a line that looks like this. And look what's happening as we go along this line as we go from left to right. When the slope is negative, the line is going down. It's falling. So as soon as I know what my slope is, I know in which direction that line has to go. If the slope is positive, I have to know as I go from right to left, then I'm going up. If it's negative, I know when I'm going from from left to right. We're always starting on the left and moving to the right. As we go from left to right, on a positive slope, we're rising. On a negative slope, we're going down. And this is a hint also then when if you draw your line and you get a line that's going up and you know the slope is negative, you know you've done something wrong. Either you found the slope wrong or you found the wrong points. But you can't have a positive slope and go down. You can't have a negative slope and go up. Again, we're always talking about the direction as we go from the left to the right. There are other things that we can learn from slope. What if I were to have 2 lines that look like this? Here's one line, and here's another one. And these 2 lines are what we call parallel. Now, we know what parallel lines mean. They mean lines that no matter how much you extend those lines, no matter how far you draw them, they're never going to meet. They're always going to stay the same amount apart. I could draw them miles long and they're still not going to meet. That's what parallel lines mean. Well, let's think about what it means in terms of their slope. Remember what the slope is telling us. The slope is telling us the slant, how much you're going up as you go across. Now, aren't these lines of their parallel slanted exactly the same amounts? Obviously, that's because otherwise they wouldn't be parallel. So it turns out that parallel lines have to have equal slopes. If the slopes are the same of two lines, those two lines have to be parallel. If the slopes, if the two lines are parallel, then you know, and you know the slope of one is -3/5. That immediately tells you that the slope of the second line has to also be -3/5. The two lines being parallel means they have the exact same slope. So let me make another comment, and then we're going to look at some problems that would involve this. I think it's it makes sense. At least I find it makes sense that two lines that are parallel would have the same slope. There's another fact that we can tell from slopes that is not so obvious. And I even can't, trying to prove it to you is going to be almost impossible, because you really have to have more mathematical knowledge. You'd have to have trigonometry, etc., in order to really be able to prove this. But you're going to have to take my word for it. It's a way of telling if two lines are perpendicular. Now, what we mean by two lines being perpendicular means the two lines are going to be meeting. They are going to cross. They're not parallel, they're going to cross. And not only are they going to cross, the angles that they make are what we call right angles. Two lines that meet or intersect at right angles are called perpendicular lines. This is another way of saying a right angle, saying it's a 90-degree angle. Now, why are we so interested in perpendicular lines? Well, if you look around your room that you're sitting in, or you can look at my board, most of the things we remember, we said a lot of the shapes, or I would say by far a majority of the shapes that are used in construction and in everyday usage are rectangles or squares, and therefore the angles are these square corners, these right angles. So perpendicular lines are lines that meet at right angles. It turns out that if the slopes are opposite reciprocals, then the lines are going to be perpendicular. Now, what does that mean? What is this? What am I telling you? So let me give you some examples. Let's say you know the slope of one line. Let's say this is line 1. Its slope is 3/5. And line 2 has slope -5/3. Opposite, meaning it's the opposite sign. Reciprocal means it's flipped over. These two lines, I don't even have to draw them. These two lines are going to be lines, they're not parallel because they don't have the same slope. They have negative reciprocal slopes, and therefore the lines are parallel, are perpendicular. Negative reciprocal means flip it over, change its sign. One's going to be positive, one's going to be negative, and they're going to be opposite. They're going to be the reciprocal, which means flipped over the fraction. The only ones that don't work that way are the vertical and the horizontal, because vertical, if one line is vertical, then it's perpendicular, it will have to be horizontal. So that's not going to be a problem. It's only when you have slant lines that you want to test if they are perpendicular. You look at their slopes And if they are opposite reciprocals, then the lines are going to be perpendicular. If I have one line whose slope is -2, well, this slope 1 is -2, then in order for the line to be perpendicular to it, it would have to be, since -2 means really -2/1, the perpendicular line would have to be 1/2, positive 1/2. So -2 being one slope, positive 1/2 being the other slope, those lines are perpendicular. So in order to have perpendicular lines, remember, you need to have two things: opposite signs and flipped over fractions. And if the number is a whole number and not a fraction, that means it's over 1. So when you flip it over, you get the 1 on top. Now, if your lines don't have opposite reciprocal slopes, and they're not the same slopes, those lines are neither parallel nor perpendicular. It just means they're lines that happen to meet. So let's say I gave you I'm going to give you the equations of two different lines. And you're going to tell me if those lines are parallel, if they're perpendicular, or if they are neither. Let's see if I can find it. Let me do this. Again, I'm going to give you the equation of two different lines. And I'm not going to ask you to graph these lines. All I'm asking you to do is find out, are the lines perpendicular, or are they parallel, or are they neither? So let's say one equation is y equals -3x plus 7. And let's say another equation is 2y plus 6x equals 22. So here's my line 1. Here's my line 2. I want you to decide, are these two lines parallel? Are these two lines perpendicular? or are they neither? So I'm going to give you a couple minutes to think about this. All right, and just put on the chat whether you think it's parallel, perpendicular, or neither. Everybody should be putting some answer on the chat. I'm going to look for that. And if you don't know, just take a guess, and we'll see how many people are right. Okay, and you need more time? Okay, 1 minute. I'll give you 3. Okay, giving you another 3 minutes. Okay, one person has answered. I'd like to see some more answers. Okay. Okay. That's an interesting answer. And okay, I see a bunch of answers. So let's see what we're going to decide. Again, if we want to figure out if the two lines are parallel or perpendicular, we've got to look at their slopes. And to find the slope of a line, we always have to put it in the y equals mx plus b format. Now, if you look at line number 1, it already says y equals. So I can tell you right away the M, which is the slope of that first line, is the number that's in front of the X, which is -3. Now, remember what I said, slope really should be written as a fraction when we're talking about it, because it really talks about something that's a fraction. It tells you what the top means, what the bottom means. So if you see -3, now, of course, in the equation, it's fine to write it -3. But if you're thinking about it, it really means it's -3 over 1. Okay, so that's the slope of this first one. Let's look at the slope at this second line. This is not in the y equals mx plus b form. So I have to put it in the slope intercept form. So the first thing I'm going to have to do is bring the -6x to the other side. So I'm going to minus 6x. This will give me 2y equals -6x plus 22. And then, since I want the y alone, I'm going to divide by 2. So this line becomes in y equals mx plus b format, -6 divided by 2, which is -3x, and 22 divided by 2 is 11. Notice, in this case, the slope is also -3, or -3 over 1, because it's the number, it's the coefficient of the x. Notice I can't do that until I have the y alone. I can't say the slope here is 6 because it's not in the right format. I have to get it into the right format, y equals, and then look at the coefficient. Remember, the coefficient means a number in front of the x. Okay, now we're looking at these two lines. Notice they have different b's. This has a b or y-intercept of 7. This has a y-intercept of 11. They're not going through the same point on the y-axis. But what about their slopes? Their slopes are the same. And isn't that what we mean by parallel lines? Lines that have the same slope, they're exactly slanted the same. Since these two lines have the same slope, but have different y-intercepts, if they both had the same y-intercept and the same slope, it wouldn't be different lines, it'd be just one line. We have two different lines here. This is y equals -3x plus 7. This is the line y equals -3x plus 11. These are parallel lines. So they do not intersect. They are not perpendicular. They happen to be parallel. And yes, Kiana, thank you. You got that right. Okay. Should we try another one like this? Ready to try another one? Okay. Here's another set of examples. Yeah. I think everybody needs a little bit of practice on this. Okay, here's my first line. That's line number 1. Here's line number 2. line number 1 is 2x plus 3y equals 9. Line number 2 is 2y equals 3x plus 10. So I want you to put both of these lines in to the y equals mx plus b form. Find out what their slopes are, and then decide if the lines are parallel, perpendicular, or neither. Okay, I'm giving you 1 more minute and then we'll do it together. Okay, let's work on this together. We want to find the slopes of these two lines so we can compare if they're parallel or perpendicular. So in the first line, I've got to get the y alone. So I'm gonna minus 2x from both sides. That will leave me with a 3y. Remember, I always put the x term first. Don't forget, it's a negative 2x plus the 9. Remember, there's no sign in front of the 9 means it's positive. I was subtracting 2x, so that one's the negative. I then divide everything by the 3. And then I look at the number that's attached to the x. The slope of this line is negative 2 over 3. Now you could either say, put the negative in front, you could put the negative, remember we talked about this, the negative on the top, the negative on the bottom. It's a negative number. The slope is negative. Also remember what a negative slope means. It means as I'm going from left to right, this line is going down. Okay, let's look at this one. It's not in the line because I'm at the speed form because there's a 2 in front of the y. I got the y alone, but I have to divide everything by 2. Notice I divide each term separately by 2. Let me just rewrite this in simplest form. So in this line, the second line, I'm getting y equals 3 over 2x plus 5. And here, the slope is the number in front of the x, which is 3 over 2. And I compare the two slopes. The first slope was negative 2 over 3. The second slope is positive 3 over 2. So number one, they're opposites. They're opposite signs. Opposite means the sign. They are opposite signs. One is negative, one is positive. And they are reciprocals. Reciprocals means flipped over. This is 2 over 3. This is 3 over 2. Therefore, these lines are perpendicular. It can't just be opposite. It can't just be reciprocal. It has to be both. If it's just reciprocals, not parallel, not perpendicular. If it's just opposite, one positive, one negative, but they're not reciprocals, neither parallel nor perpendicular. In order to be perpendicular, they have to have both features, opposite signs and reciprocals flipped over. Parallel lines have to have the same exact slope, which means that sometimes one is 3 over 1 or just 3 and the other one is 6 over 2. You got to reduce it so you can compare them. They have to be the same number. If they have the exact same number, they're parallel. If they have opposite reciprocal slopes, they are perpendicular. Is that clear? Is there any question about this? Okay. Then I think I'm going to turn off number 1, the recording.